We have a super interesting keynote coming up, the second external one, and this is about connected hypercars. So for you that fancy those kind of cars, that will be a moment of joy. I can really see that coming. So here on stage we have Axel Ingólfsson from Koenigsegg. Welcome, Axel.
Hello everyone, my name is Axel, happy to be here. I'm an engineer at Koenigsegg Automotive. I've been with the company now for the past 4 years, will be in December this year, working on Koenigsegg's connected car solution, along with a mobile application that the customers use to interact with their cars online. Now, today I'm here to talk to you first a little bit about Koenigsegg itself, what it is that we do at the company, how Koenigsegg ended up building some of the fastest and most extreme hypercars in the world. And secondly, I will tell you about our connected car solution and how we rely on Telenor's network to keep our cars constantly connected to the cloud. Now, this timeline here represents more or less the history of Koenigsegg, ever since Christian von Koenigsegg founded the company back in 1994. I joined the company here in the Regera era. The Regera was made in 80 units total, just to give you an idea of how rare and exclusive these cars are. The Jesko next up will be made in 125 units, the Chimera in 300. So it's not exactly mass production that is going on here. Now, Koenigsegg has always been known for innovation and breaking records. And that started all the way in the beginning with the Cc850, the first production car of the company, coming out in 2002. It was the most powerful car in the world, most powerful production car in the world. Next, after that, we had the CCR in 2004, the fastest car in the world. It reached a top speed of 387 kilometers per hour, beating the iconic McLaren F1 at the time. It also went around the world and beat numerous track records, including the Nürburgring record. The CCXR, it was the world's first green hypercar. It was the world's first hypercar that could run on sustainable fuel, ethanol. Then we have the 121, which was, again, the world's most powerful car with 1 megawatt of power. It was also the world's first production car with a power-to-weight ratio of 1 to 1, which means equal amount of kilograms and horsepowers. Thus, the name Koenigsegg 1 to 1. Continuing with the records, the Agera RS in 2017 became the world's fastest production car again. It reached a top speed of 458 kilometers per hour on a closed-off road in the desert in Nevada. It's really hard to imagine how fast that speed really is. There is a video on YouTube from that day where that record was set. I recommend that you take a look at it. I will link it in the end of the presentation, where you can just see how fast the white road markers on the road and the landmarks beside the road pass you. It's really insane to watch that. Now, the Agera RS also had the world's fastest, or world's shortest 0 to 400 back to zero run, which it did in roughly 33 seconds. And it held that record until it was beaten by another Koenigsegg, the Regera, 2 years later by almost 2 seconds. We also have a video on that I will link in the end of the presentation. Now, the focus at Koenigsegg has always been about ultimate performance, no compromises. When the Regera came out, more focus was put on luxury and comfort. It was our first car with a fully robotized bodywork, so the doors could be operated remotely from the key fob and the hoods as well. And there is a button on the key fob with a ghost on it. If you press it, the doors and the hoods will open simultaneously. It's really cool. It's a nice party trick. It's a hybrid car. It has a combustion engine in combination with the world's first 800-volt electric powertrain in a car. And what's unique about this powertrain is how it combines these two power sources, how it leverages torque from these two different power sources. Because in the Regera, there is no gearbox and there is no automatic transmission. Instead, the Regera has this, the Koenigsegg direct drive. You can think about it as a manual transmission with only one gear, the gear that you would use to take the car up to its top speed of 400 kilometers per hour. Now, in a conventional car, obviously that wouldn't be very effective. So in the Regera, that's where the electric motors come in. They help keeping the car very fast and snappy at low speeds. So throughout the whole RPM range, the combustion engine and the electric motors are working together, but at low speeds, most of the torque is coming from the electric motors, and high speed, most of the torque is coming from the combustion engine. Just another example of innovation of the company are the air core hollow carbon fiber wheels. Now, these are the world's first hollow design carbon fiber wheels. The benefit of that is that while the wheels are incredibly strong and rigid, they become very, very light, which is, of course, a benefit in a performance car. We used them first in the Agera series, and they've been used ever since. They come in multiple designs and shapes, or customers have a wide range of wheels to choose from. And they were actually on that car that reached a top speed of 458 kilometers per hour. So to that speed, they have been tested on the road. And in addition to that, they have been bench tested up to 500 kilometers per hour. People sometimes wonder why put so much effort into reducing the weight of something so critical and crucial as the wheels. Well, it turns out that when you shave weight off the wheels of the car, you're not only shaving weight off the vehicle that you're accelerating forward with the car, but it's actually quite important here that the wheels spin up. So you're also saving weight, you're also saving the amount of angular momentum that the car needs to build up to accelerate. So you're saving weight here that results in benefits on two different fronts, which results in both in increased ability for the car to accelerate. Now, next up here is the Jesko. The Jesko is more considered a successor to the Agera series than the Regera, in the sense that this is a little bit more back to the basics. It's a combustion engine only, ultimate performance, no compromises. Now, this car is currently in production, and it's an extreme 1600 horsepower racing machine engineered to break records. It comes in two varieties: the Jesko Absolute, which is a top speed optimized version designed to go very, very fast on a straight line. And then we have the Jesko Attack, the one you see here behind me, which is designed to go very fast around the track. Corner really well, which, for example, there's a lot of differences between these two cars, but perhaps the most noticeable, visually speaking, is this massive rear wing at the back of the car. And it's there for ultimate downforce, which will improve the grip around the track for cornering, etc. If we compare that to the Absolute, for example, you see that there is no rear wing. Instead, we have these jet-shaped fins, carbon fiber wings that are there for high-speed stability. The car is also a little bit longer. It has covered rear wheels with removable covers, and it's actually completely redesigned with respect to aerodynamics to decrease drag at very high speeds. Now, keep in mind that air resistance grows exponentially with speed. So at very high speeds, let's say north of 400 kilometers per hour, pushing the car up just 1 kilometer per hour takes an enormous amount of additional power. That's why it's so important to minimize drag. Now, the Jesko comes with a lot of cool technologies, one of which is the light-speed transmission, as we call it, the Lst Transmission. This is a revolutionary 9-speed transmission that can shift from any gear to any gear seamlessly in just milliseconds. It has 7 clutches, not just 1 or 2. So 1 for the reverse gear and 6 gears for going forward. Essentially 1 clutch for each gear in the gearbox. It's good to think about it that way. Now, and these gears, along with their clutches, are aligned in a way that results in 9 different possible gear combinations, or 3 times 3. So it's a nice 9-speed transmission. And because of this design, with only 1 clutch for each gear, there's no need for a flywheel, which tends to be quite a heavy and spacious part in a transmission. There's no need for synchronizers, so you end up with a very lightweight and compact design. The only thing really needed to shift gears is to engage and disengage clutches. And you can actually do that simultaneously. You can start engaging the speeds for with the gears for your next speed while you're still disengaging the clutches for your previous speed. So there's no dead zone between the gears. There's no neutral. So while during those milliseconds that it takes to shift gears, you are actually gaining speed. You never stop gaining speed. Next up here is the Koenigsegg Chimera. It's another hybrid, more comfortable and surprisingly practical. You can easily fit 4 2-meter-tall people in the car along with their carry-on luggage. There's space for 1 luggage in the front and 3 in the back. We actually have a video on that on YouTube as well, where 4 guys from the factory, all around 2 meters, get into the car. And it's quite nice to see how easy that is, because it's typically not the case with cars in this category, hypercars like this. I will link that video also in the end of this presentation. Now, along with the fact that you see these giant iconic doors, and those in combination with the fact that there is no B-pillar and the car is very spacious, makes it very easy to get in and out of the car. And like the Regera, the Chimera is a direct drive car. It has 1,700 horsepower, and it's our first 4-wheel drive car. And this was our latest car until just a couple of weeks ago. Some of you who have been following our social media lately may have noticed that Koenigsegg just announced yet another hypercar, the Koenigsegg Cc850. Now, this year, there are 20 years since the original CC8 came out. And Christian von Koenigsegg, the founder of the company, he turns 50. He turned 50 this year. So this is an anniversary car. The original plan was to make it in 50 units, so a little bit less than the previous models that we've been making. But they sold out instantly, and in the end, it was decided to add 20 more, so it will be made in 70 units total, and still nowhere near meeting demand. It has a gorgeous, timeless design with a lot of references to the original CC8, but it's not only visual references. The original CC8 came with a 6-speed manual transmission, and this one also has a 6-speed manual transmission, which is not common in new cars that are coming out today at all. But it's a very unique transmission. In fact, it runs on top of the light-speed transmission, the one in the Koenigsegg Jesko. So instead of paddle shifters, you actually have a traditional gear lever, which is operated by wire, and you have also a traditional clutch pedal, which is by wire as well. Now, here on my next picture, I actually have my next slide, I have a picture of the gear lever. So you can see here on the left side of the transmission, you actually have 6 traditional gears. And if you pull the lever all the way to the right, you have the reverse on the top. Then you have the drive, like in any automatic car. So you have the best of both worlds. If you want to, you can drive the car in fully automatic mode, or drive it like a manual car with a clutch pedal. Now, Koenigsegg has been playing around with a connected car solution now for almost a decade. A prototype of the cloud was presented on Geneva Auto Show in 2014, and a fully working version was launched a year later. The motivation back then was to serve a mobile application for the customers and to serve over-the-air updates to our cars. Now, people sometimes ask, where do our customers come from? Where can people afford cars like these? We currently have 47 dealerships across the globe. I'm not going to give you the address of our customers, but you can see here on this map where our dealerships are located. And that more or less represents also where our customers can be found. And it's very important for us to keep the uptime as high as possible. And that's where Telenor's network has been serving us very well. Now, I like to think about the cloud as serving 4 main different purposes. To some degree, this is a hindsight explanation, but it is interesting to see also how the way we use things sometimes change over time. Now, first off, our technicians, they rely on real-time data from the cloud to keep track of the health of our fleet and to be proactive in the way they deal with any arising issues. Now, at Koenigsegg, we dedicate an enormous amount of time and resources on each customer. So we have an opportunity there to build very personal and direct relationships with our customers. Our technicians, they monitor clutch wear, engine oil level, battery state of charge, tire pressure, etc. And they get notified if something comes up, such as a check engine light or a low battery state of charge. And they are on the issue within 48 hours, and usually it's a lot shorter than that. Often it is actually we who notify our customers that something needs our attention, not the other way around. Secondly, we use the cloud to serve over-the-air updates to our cars. Now, it's not uncommon that car manufacturers today have some sort of over-the-air update capability. Typically, this would involve, for example, updating infotainment system over the air, which tend to run on Linux systems, which need to be kept up to date just to be kept secure as vulnerabilities keep getting discovered. What's impressive about our solution is our ability to perform over-the-air updates on embedded systems. Now, modern electronic systems in cars are generally very decentralized compared to how this was, let's say, 10 or 20 years ago, in the sense that instead of having multiple sensors and actuators connected to just a few controllers in the car, you have multiple computers, as we call nodes, distributed all around the car with limited purposes. We have around 30 individual nodes in our cars, one, for example, for the left door, one for the right door, one for the electronic stability system, one for each headlight, and so on. And we can update all of these nodes over the air. And this has been very useful for us, for a company that is fast-moving, fast-paced company and very innovative, because you can react to things very quickly. Now, my third point up here is data-driven development. This is not a new topic, obviously. It's nothing new to the web industry. For example, the social media engines, they monitor the way you like to perform your tasks, the features you use, which features you don't use. They collect feedback from the users and use this data as a bedrock when planning upcoming features and when prioritizing their backlog. At Koenigsegg, we do data-driven development as well. We can see how cars behave in 40 degrees Celsius in the Middle East or much colder climates here in Scandinavia. And our engineers, they use this data to tune their parts that they're working on. Now, lastly, we use the car to serve our mobile application. Last year, Koenigsegg released a mobile application that our customers can use to locate their car on a map. They can view the owner's manual. They can get notified when software updates come. They can monitor ongoing software updates, and they can view some telemetry data such as battery state of charge, fuel level, etc. And let's say for customers that have a garage full of hypercars, this can be very beneficial just as a peace of mind to make sure that you locked the car and you left it armed and locked. And our ambition is to use this app as a quick way of communication when something needs attention from the customer. And all this is taking place in our factory in Ängelholm. We have actually two factories now. We are located a few kilometers outside Ängelholm on our old airfield. And we also have part of the production now and our warehouse in Älvdalen in Ängelholm, not to be confused with Älvdalen in Dalarna. There's actually a place in Ängelholm called that as well. And we are expanding the main factory. The black building you see here is brand new. It's crazy how fast they build these things this time. Last year, a year ago, there was no traces of this building whatsoever. And now, at least from the outside, it looks kind of ready. It's not only the buildings that are expanding, also our team is as well. When I started at Koenigsegg in 2018, we were about 180 employees. Now we're about 550. And we're very proud to say that we have people from 45 different nationalities working at the company. And our ambition this year is to hire 100 more engineers and 150 new production staff. Thank you very much for listening. You can find us on all the main social media engines. The videos that I referred to during the presentation, you can also find them here embedded in this QR codes. Thank you.
Thank you, Axel. A great presentation, great story. Do you see that the electrification of the car industry will affect the competitive landscape also within hypercars?
Well, I would say generally speaking, if we would do it within hypercars is a different question, but I would say generally speaking, yes, it has already done that. If we look at companies such as Tesla and Rivian, and new companies that are exclusively focused on electric cars, I mean, the automotive industry is very conservative in the sense that the brands you see outside today are more or less the same brands that we've seen for decades. And I'm sure there are loads of reasons for that, but I think at least one of them is that it's just so hard to build a car. And if you have a history and a legacy and you have previous models to base on, you just have so much leverage when doing that. Now, if you need suddenly to replace the entire powertrain, which affects more or less the whole entire vehicle, you don't have as much advantage anymore. And there opens up an opportunity for new competitors to come in. Whether that opportunity is still open or if it's closing, I would say it's hard to say. But I think that will probably depend at least on how future technological advances in that realm will be.
And from a connectivity or IoT perspective, do you see that the use cases will evolve with the electrification?
Well, at Koenigsegg, we already have 2 hybrid cars, so the Regera and the Gemera, and we do log to some degree different data, for example, for these cars. But I wouldn't say that there is any fundamental difference between that data and the data that we log for our combustion cars, even if it's a bit different. Now, with that said, if we look at the mechanical components that we have today, for example, our manual transmission or our combustion engines, there's so much more automation in these things than it used to be back in the days, and so much more electronics and high-frequency electronics. And if we want to keep locking that, and especially if we want to be remotely controlling that in some sense, then I can definitely see that putting some more requirements on IoT providers.
Thank you, Axel.
Thank you.